In this lesson, we're going to take a look at something called counting principles. And before we get too far, I know a bunch of you are probably rolling your eyes thinking, come on, Ray, we know how to count. This isn't tough stuff. That's not exactly what we mean by counting principles. What we're really looking at is how to count the number of ways that something can occur. And we're going to be looking at some pretty straightforward but very powerful methods of doing that. And then as we work through our unit, we're going to look at lots more advanced ways of doing it for different situations. So rather than going through a whole lot of description, let's just jump into some examples and see how it works. For starters, we're going to have a young couple that just had a baby boy. They want to determine a first name from the mother's side and a middle name from the father's side of the family. So the first name of the child is either going to be Alex, Bob, or Carl, and the middle name will either be David or Edward. And if you're keen, you might notice that the first letters of those names may have some significance to why I chose them, but that's the ones that we're going to use anyway. So now we want to list all the possible names for the new baby. And we can try to do this in sort of a systematic way. How we do that exactly is not important, but as long as we follow some kind of systematic process so we don't miss any. I don't want to just start in by saying, well, there could be Carl Edward or Bob David or Carl David or Alex Edward, and in kind of a random order. I want to approach it systematically. So I am going to just use the first letter of each name rather than write out the full names, just to save us a little bit of time. And I'm going to start off with the first name can be Alex, and then the second name can either be David or Edward. So I'm going to do Alex David, Alex Edward. And then I'm going to move up one for my first names and either do Bob David or Bob Edward. And lastly, I can do Carl David or Carl Edward. Okay, and I'm going to point out that there are 6 possible names for our new child given the criteria that we've been given. And in many of the situations that we're looking at, we're actually just going to be looking at the number of outcomes, not listing them all. And in a case like this where there's only 6, that's not a big deal. But in several of the cases we look at, the answers will be in the hundreds of thousands, and we definitely do not want to have to list all the possible outcomes. So, for instance, I do not want to have to list all the possible lottery ticket winners that could possibly be out there. I mean, it could be 1, 7, 13, 22, 25, 29. It could be 16, 14. There's a lot. There's a lot. In fact, depending on which lottery you're looking at definitely answers in the millions. So listing every possibility is just not a realistic way of doing things. Now, what we can do with that, instead of just listing them in an order, we can do something called a tree diagram. And a tree diagram is basically again, a systematic approach on how to do things. And here's how we draw tree diagrams. I'm going to try and see if we can remember the data from above. It's either A, B, or C, and D, E for our second choice. And I'm also going to point out that tree diagrams can be drawn in different ways. Usually they're drawn top to bottom, so like an upside down tree, and sometimes they're drawn left to right, like a sideways tree, neither of which really looks a lot like a tree. But the method of drawing them is the same. So what we're going to do is I'm going to draw mine sideways for now because it just is a little bit easier as far as organization goes, but I want to make it clear that you could draw them in other ways. You can draw them from top up, bottom up, top down, etc. Okay, so the first mind-blowing procedure is we're going to draw a dot, and that's going to be the starting point for our tree. And then what we do is each time we branch out, it's going to represent one decision or one thing that happens. So the first thing that's going to happen is we have to choose a first name. And by the way, you don't need to write this at the top. I'm just writing it here to remind us what it is we're actually going to do in our first choice. And then we have branches for each of our possible outcomes. So I'm going to try and draw them more or less spaced evenly. And I can either do Alex, Bob, or Carl. So those are my 3 possible branches for my first decision, which is first name. And then middle name. There's 2 choices for each of those. So each of those is going to branch in 2 ways. So it's going to be David Edward, or David Edward, or David Edward. Okay, and then we're done. We've done all the possible decisions. And what I want you to note, as I'm just going to highlight one of these as an example, is that each possible way of getting from the base of the tree to the end is going to represent one possible outcome. So for instance, if I follow the tree this way, that represents the example of Carl David as my possible outcome. And if I follow any other branch, I get another name. And as we can see here, there are 1, 2, 3, 4, 5, 6 possible ways to get from the starting point of our tree to the ending point of our tree, which represents the 6 different names that we figured out in the last part. Okay, we are now going to give a second hyphenated middle name to our child, which will either be Fred or Gary. And then we want to see what our outcomes will be in that situation. I just realized now that I made a little bit of a mess on this by putting in the yellow, so I'm going to erase that, the yellow stuff. There we go. And rather than draw the diagram from scratch, I'm going to continue on where we left off. Okay, so Fred or Gary, that would be F or G. So this is going to be second middle name. And now what I think you're going to see is that even by the time we get to a third branch, and this is with very few options when it comes right down to it, we're starting to get very squished. And that's what makes tree diagrams kind of fall apart, is that if there are too many outcomes, even though it's a beautiful way to organize work, it still becomes very difficult to actually fit it in so that it looks reasonable. So I'm going to try and get them all in here, and each of those will be Frank or Gary. And I think you can see now that there'll be 12 possible outcomes for our names. We have 3 choices for our first name, 2 choices for our first middle name, and 2 choices for our second middle name. Okay, and again, any branch, I could draw one on there, but if we wanted to get, for instance, to here, our choice would be going down to Carl, up to David, down to Gary. So Carl, David, Gary. And then whatever this kid's last name is, I'm already feeling sorry for him with all these names, but it is what it is. Sorry, kid, you're a math example. Okay, so we've extended it to include the second middle name. We're good to go on. Okay, now we're going to look at the fundamental counting principle, which is often known just as the rule of product. And I want to be clear in case any of you have taken calculus that the rule of product is not the same thing as the product rule. Product rule is for derivatives in calculus. The rule of product is a counting principle, and they are not the same thing. Okay, that said, the rule basically says that if we have 2 different actions that are performed, whatever they are, and the first one has m different outcomes, and the second one has n different outcomes, then the number of ways we can do both is m times n. So going back to our example that we've already done, I'm going to actually go back to here. Just for the first name and the middle name, before we extended it, we had 6 possible outcomes. And that was because we had 3 choices for our first and 2 choices for our second. And 3 times 2 gave us 6. Now we can extend that, and since we have 3 choices and 2 choices and 2 choices, that would be 3 times 2 times 2, which is 12. And that was the number of outcomes we got once we added in the second middle name. So that's the rule of product. Okay, so as an example, during silent reading, a student goes to the front of the classroom and picks something to read from 20 magazines and 35 books. They want to select both a book and a magazine. How many different combinations of reading material might they select? Okay, so they get to choose a magazine, and that's 20 options. And this is the important word here, the and is what we want to look for. And 35 books means they're choosing a magazine and a book. They're doing both of those things, not one or the other, but both. So we multiply them together. So there should be 20 times 35, which is 700 possible choices. Okay, that wasn't too tricky. I think most people can kind of see this. Now, if we did this as a tree diagram, which we could if we had a lot of paper and a lot of time and could put up with mind-numbing boredness, But if we listed our 20 possible books and our 20 possible magazines and 35 possible books, the first choice would branch 20 ways, and then each of those 20 would branch 35 ways to give us a total of 700 possible outcomes. But again, once we're getting this big, listing the possible outcomes, like listing like I don't know, I read Time magazine and Harry Potter, the Philosopher's Stone. Like listing every possible outcome of 700 is not realistic. So we're just talking about the number of possible outcomes. Okay, the rule of product has a very close friend and partner called the rule of sum. And the rule of sum is a little bit different, obviously, or it would be the same rule. And it's kind of going back to the rule of product. If we have two actions, one can be performed m ways, one can be performed n ways, and we want to do the one or the other, not and, but or, then we add the outcomes together. So in this case, the student is going to pick a single thing to read. It's either going to be one of the books or one of the magazines. Not one of each, but one or the other. And as soon as we go to the or, it's going to be addition. So in this case, I'm just going to do 35 plus 20 equals 55 options. And that makes sense if you think about it. There are 55 things with pages. I don't want to say books because I've differentiated books and magazines, but there are 35 things with pages at the front of the room, and I'm going to choose one of them. The fact that one's a magazine or a book doesn't seem to matter in this question. It's just one or the other. So 55 possible options. Two very straightforward rules that are very powerful. Just before we go on, I'm going to reemphasize that the and, when we do something and another thing, it's going to be multiply. And when we do something or the other thing, it's going to be add. Now that said, English is a horrible language. So we have to be careful. Even though English may use one of those words, it may actually not mean those words. Just let's keep that in mind as we move forward and see if it comes up anywhere. I think it might. Okay, so let's mix these rules together a little bit to do slightly more complex questions. So you just invited or received an invitation to your cousin's wedding. He knows that people like a choice, so he has several different meal options available. So on your invitation, you get to choose between super salad for your starter. You then get to choose beef, chicken, or pasta for the main course. And for dessert, you can choose from 4 different pies and 2 cakes. So how many different meals could be ordered? Okay, so the first choice we have to make is starter. And normally you don't write down the words here, but since this is the lesson and I'm trying to explain where it's coming from, I'll write it down. So we have a starter, a main, and a dessert. Okay, so the starter part is going to be a soup or a salad. Now, most people, without even thinking about this, and the way that we'll do questions, we actually will do it this way. Most people just write down there's 2 options there because soup or salad. 2 options. However, I'm going to write it down using the rule we just did because soup or salad means one choice or another choice. Now, of course, like I said, when we get into doing these actually practically, you're just going to write that as 2. You're not even going to think of it as 1 plus 1. Okay, so we've chosen our starter, and we're not going to get to eat like a starter or a main. We're going to get to choose a starter and a main. We're going to also obviously get a main course. And because of the and, we're going to multiply. For the main, we have beef, chicken, or pasta. Again, the or here means you get beef or chicken or pasta, one or the other, not all of 3 or not 2 of the 3. And so I could write this as 3, but again, I'm just going to write it right now as 1 plus 1 plus 1. And then for dessert, we also get a dessert, so that's an and. We don't have to choose a dessert or a main course, so and. And we get to choose from 4 different pies and 2 different cakes. Now, I want you to read what that says, and I want you to think about what it means, because I do unfortunately see the word and in there, but I don't think the intention here is that you get a pie and a cake. I think it's you get to choose a dessert from pies and cakes, but you're either going to have a piece of pie or a piece of cake. So here's where English messes things up. The word it says in the sentence is and, but the intention is or. I know that confuses some people. Luckily, it's not usually a huge stumbling block, but you do need to think about what the intentions of it are. Does this mean you should get pie and cake, or does it mean you get pie or cake? And it means or. Okay, so desserts, we have four choices for four choices for pies, or two choices for cakes. And then I'm going to just simplify this down a bit. 2 times 3 times 6, which is really what, in most cases, most questions, once we get going, that's exactly what I would write out as the first step. 2 choices for starters, 3 choices for mains, 6 choices for desserts. Even though it says 4 and 2, I can add that pretty easily in my head to see that there are 6 possible options for dessert. And then we have 2 times 3 times 6 is 6 times 6 is 36. So that means that going to this wedding, we have 36 possible meal options. Okay. Just to reiterate again, and, at least when it means and, when we have to do something and another thing, we're going to multiply. And whenever it's or, we do something or another thing, then we're going to add. Okay, so now let's take a look at this example here. Some of you may have seen these combination locks. They look kind of like this. Test my drawing skills here. Little things on the ends, and then they connect them with the wires, or the whatever that thing is that comes out of both sides. I don't want to say wire, string, whatever. But there's 4 dials here. And you turn those dials and you have to line them up with a specific combination that usually lines up down the middle here to get it to work. So there's your bike lock. It has 4 dials. Each of the dials has numbers from 1 to 8. And the question is, how many different possible combinations could we make from that? So I want you to take a moment and think about that. If you want to pause the video and think about it, that would be fantastic. Try it on your own and then come back and we'll see if your logic makes sense. Okay, assuming that you paused it and have already tried it, let's think about this. So we have 4 dials. What does that mean? Well, the first dial, we have 8 choices. We can set it to number 1, 2, 3, 4, 5, 6, 7, or 8. So that's 8 possible choices for the first. And then we have to choose a second number, a number on the second dial. That's also 8 possible choices. And then a third number, and then a fourth number, all of which are 8 possible choices. Now the question is this ands or ors? And I don't think for a combination lock, you just have to choose one number on one dial and then call it a day. I think we have to choose a number on each dial. So we're choosing a first number and a second and a third and a fourth. So I think it's going to be multiplication. And as the heading there might suggest, shortcuts using exponents, anytime we're given a similar choice over and over again. So in this case, the dial is changing, but what we're doing is still choosing a number from 1 to 8. So anytime we have kind of a repetition of choices, we can actually save ourselves a little bit of time and say that's just equal to 8 to the exponent 4. And then 8 to the exponent 4, I think, is 4,096. Yeah, 4,096. Okay, so that's how many possible combinations we could make with that lock. Okay, so that's the lesson. It seems pretty straightforward. The reality is you're only going to get better at the tricks in this if you take a look at questions that have those tricks. So do the homework, try it. If you're stumped on something, let me know. Otherwise, good luck.